Brought to you by Thomas Allgaier and Freenos, this edition highlights key LinkedIn posts on electrification and battery technology in weeks 4 and 5. Freenos supports automotive enterprises and consultancies with market and competitive intelligence, so product teams and strategy leaders do have the optimal base for their strategic decisions. You know, when we sit down to look at the mobility feed, it's usually, it's a lot of noise. Shiny concept cars, press releases about partnerships that might happen in 2030.
Maybe, potentially.
Exactly. But looking at the data from weeks 4 and 5 of 2026, something just felt different.
Heavier.
It definitely felt heavier. The whole conversation has shifted. We're past the dreams phase and straight into the concrete phase. We're not seeing posts anymore about if we're going to electrify.
No, that debate feels pretty settled.
Right. Now we are in the messy, expensive, but also fascinating phase of figuring out how to actually plumb all this hardware into a grid that, it just wasn't designed for it. Precisely. So our mission for you today is to cut through that noise and find the real signal. And the signal we found covers 4, I think, really distinct clusters. We're going to talk about the grid, which is, spoiler alert, basically the boss of every project now. Mm-hmm. We're looking at heavy-duty charging, moving from PowerPoint slides to, actual pavement. Mm-hmm. We've got a really uncomfortable comparison between U.S. and EU reliability. Sorry, in advance to our American listeners.
Yeah, that one's a bit spicy.
And finally, the battery loop, where regulations might be writing checks that reality can't cash just yet.
It's a packed agenda.
Yeah.
And what I really like about this specific stack of sources is that they aren't glossing over the problems. They're highlighting the friction. And for anyone listening who's in strategy or product, the friction is where the opportunity is.
So let's start with the biggest source of friction, theme 1, grid and system integration, or as I've kind of started calling it, the project killer.
It's a fair nickname, unfortunately.
It used to be all about the charger itself, right? Does it look cool? How fast is it? But a post from Jordan Marsden this week just made it so clear that era is gone. He was pretty blunt about it.
Oh, blunt is the right word. Marsden basically argues that the grid isn't just a technical detail you sort out at the end. He says, and this is the quote, "The grid is the project."
Wow.
Yeah. If you don't have that connection, you don't have a business model. It is that simple.
But why is it such a bottleneck right now? Are we just running out of power?
It's not necessarily a lack of generation. It's more about access in the process. Marsden flags 3 specific pain points. First, oversized queues, everybody's trying to plug in at once.
Okay.
Second, reinforcement cost that he literally describes as eye-watering. But the third one, this is the real killer for anyone trying to build a plan. Timeline uncertainty.
That's the one that got me. He mentioned projects could take anywhere from 18 months to
4 years?
To 4 years. How do you even build a financial model when the utility says, we might connect you next year, or maybe in 4?
You can't. That's the thing. You're just burning capital while you wait.
So the insight here is you have to treat the grid as your first step.
From day one, you don't design the site and then ask for power. You find the power, and then you design the site around what's actually available.
Okay, but even if you get connected, the pain doesn't stop.
Yeah.
This next point, it actually blew my mind. I'd never thought about the physics of, doing nothing. The post from Micah Zawisa about reactive power.
Oh, this is fantastic technical nuance. And it is costing CPOs, charge point operators, thousands. Many of them don't even realize why.
Okay, so break this down for me, and for anyone listening who didn't major in electrical engineering. Zawisa is saying operators are losing money even when they aren't charging cars.
Essentially, yeah. In an AC system, you have active power. That's the good stuff, the juice that charges the battery. But you also have this thing called reactive power, which is energy that just sort of bounces back and forth on the wire to maintain voltage. It doesn't do any real work.
It's like the foam on a beer.
That is the classic analogy, yes.
Yeah.
You pay for the whole pint, but if half of it is foam, you aren't getting what you paid for. And Zawisa points out that utilities will actually penalize you if your power factor, your beer to foam ratio, is too low.
And the chargers themselves are the problem.
Correct. He notes that a lot of high-end chargers will advertise a 0.99 power factor, which is great. But that's only when they're running at full blast. When they're idle or just trickling a charge into a car, their efficiency tanks. They start generating a lot of that foam, so to speak.
So you have these super expensive assets just sitting there, not making any money, and they're racking up utility fines because of bad physics.
Precisely. And his takeaway isn't just pay the fine. It's a call to action for the hardware manufacturers. We need better firmware, better filters to handle these low-load scenarios.
So, okay, the grid is slow to connect and it's expensive if you mess up the physics. It sounds like a complete nightmare. But we did see some hope in the feed. People aren't just sitting around waiting.
No, absolutely not. Necessity is the mother of invention, right?
Right.
And you just have to look at the story from Luc Van Cook about DHL.
This is a massive rollout, something like 2,500 electric vans.
It's huge. And traditionally, if you go to a grid operator and ask for enough power to charge 2,500 vans at once, they would. Well, they'd laugh you out of the room and tell you to come back in 10 years.
So DHL didn't wait.
They used software to, let's say, optimize the system. Luke detailed this hybrid energy management system. It's got local controls on site, reacting second by second, but it's also connected to cloud oversight.
So like if the office building turns on the air conditioning, the chargers automatically dial back a little.
Exactly. And the result is just staggering. They're charging almost twice as many vehicles per night as their grid connection should theoretically allow. No new cables in the ground. They just squash the peaks.
That ties in perfectly with what Nicholas Lurch was talking about with the FLA Xbox.
Yes. The FLA and Xbox is kind of the hardware answer to that software problem. It's a controller built specifically to meet these really strict grid requirements like the ones in Germany without delaying the rollout.
So the bottleneck isn't always the wire?
No, sometimes it's just about having the right brain controlling the flow. And Philip Graf made a great point on this too, saying battery storage alone isn't some magic wand. You need intelligent logic to decide when to charge the battery and when to sell back to the grid.
Right. So the summary for this whole grid cluster is pretty clear. The era of plug and play is completely over. We are now in the era of plug, manage, optimize, and pray you did your math right.
That's a good way to put it.
Which brings us to theme 2. If the grid is already stressed out by delivery vans, what on earth happens when we start plugging in the real monsters? We're talking about heavy-duty charging, moving the megawatts.
This is where the numbers get, well, both scary and exciting. We're going from kilowatts to megawatts.
And the big headline this week came from the U.S. We saw a bunch of posts. Jovan Filipovich, Jason Gies, Peter Diamond, John Jerikas, all talking about the same huge partnership.
Tesla and Pilot Flying J.
Exactly.
And this is significant. For a long time, the Tesla Semi felt like this, captive project. You only saw them hauling chips for Tesla or soda for Pepsi. This changes that completely.
They're building a public network.
Real public infrastructure.
Yeah.
We're not talking about some slow charger tucked in a corner. They're deploying 1.2 megawatts per stall.
1.2 megawatts. Just to give you some context, that's enough power to run a small neighborhood. All of it channeled into a single cable.
Into a single truck, yeah. And they're putting 4 to 8 of these stalls at each site, right along the I-5 and I-10 corridors. This is strategic. These are the main arteries of American logistics.
It feels like a real turning point, but I did like the counterpoint that Chris Jackson raised. He saw all this excitement about public charging and basically said, that's cool, but that's not where the real work happens.
Jackson is the voice of operational reality here. He's arguing that 60 to 90% of all heavy-duty charging is going to happen at private depots.
Your depot is the infrastructure. That was his line.
That was it. He's warning fleet operators, don't wait for a national network to be finished before you buy trucks. The depot is where the truck sleeps. That's where the bulk of the energy transfer is going to happen. Public charging is just your insurance policy.
But even at the depot, you have to be smart about it. And this leads to my favorite story of the week, the Ali Sud Distribution Center in Germany. This was shared by Syed Hasib Hassan.
Yes. This is a brilliant example of what we call opportunity charging.
So walk us through this. Usually a truck drives all day and it charges all night. What is Aldi doing differently?
So they just looked at their operations and they realized a truck isn't always moving. It spends about 60 minutes at the dock being loaded with groceries.
Dead time.
Traditionally, yes, but Aldi installed 250 kilowatts chargers right there at the loading dock. So in that 1 hour, while the truck is just sitting there anyway, they pump in enough energy for another 125 to 140 kilometers of range.
That's free mileage. I mean, not electrically free, but operationally free. You aren't stopping the driver.
Exactly. And Syed mentioned they're already future-proofing those docks for 375 kilowatts. And just think about the implications of that. If you can get your full route's energy while you load, maybe you don't need a massive, heavy battery.
You could use a smaller battery, carry more cargo.
And never stop at a highway charger. It solves multiple problems at once. And it's not just trucks. Ui Pietriga and Tommy Rentacartano were posting about this tech hitting the maritime world.
The Megawatt Charging System, or MCS, in ports.
Yes, for those giant electric straddle carriers that stack containers, in a port, uptime is everything. A port never sleeps.
Right.
If a machine takes 4 hours to charge, you need a second machine. That just destroys your TCO. With MCS, you can blast power into it during a shift change and keep your fleet small.
But I have to play the skeptic again. We just said the grid is constrained. Now we're talking about blasting megawatts into trucks and port cranes. Dr. Hussein Basma shared a demo suggesting this won't actually crash the grid.
It's a valid fear, but his post about the Kempower site in Sweden proves it's solvable. They had a site delivering megawatt-level charging, but they didn't pull megawatts from the grid.
They brought their own bucket.
A very, very large bucket. A 2.4 megawatt-hour battery storage system plus 400 kilowatts of solar panels on site. They buffered everything. So the grid sees this gentle, steady trickle while the truck sees a fire hose.
So heavy duty is possible, but you basically have to build a mini power plant at your depot.
In a lot of cases, yeah. That's the new reality.
All right, let's shift gears. Theme 3. We've connected to the grid, we've bought the big trucks, now we have to actually run the network. And this is where things get a little embarrassing if you're in the U.S.
The transatlantic gap. It is definitely getting wider.
Casper H. Rasmussen posted some data that really felt like a beatdown for the U.S. market.
It was hard to argue with. He was comparing the maturity of the EU versus U.S. infrastructure, and the numbers were just stark.
Let's talk about that utilization stat.
Okay, so he noted that the median public DC charging site in the EU is doing about 57 kilowatt hours per day.
Okay.
In the U.S., 33.
Wow, that's almost double the traffic in Europe. Why?
It's reliability and standardization. Rasmussen points to the connector soup in the U.S. You've got CCS1, the new NACS, legacy CHAdeMO. It's a mess. In Europe, they settled on CCS 2 years ago. It's boring, and boring is good for business.
And then there was that uptime issue. He had that line about rural Nevada.
A broken charger in rural Nevada might wait weeks. In Europe, the density is higher, service networks are tighter. If a charger breaks in the Netherlands, someone's there the next day. In the U.S., you pull up, and it's a coin flip whether it even works.
Which just creates more range anxiety, which lowers utilization. It's a death spiral.
It is. And this leads right into what Patrick Rolke was talking about with the lights-out CPO.
Okay, that sounds like a sci-fi concept. The automated operator.
It's the only way to scale, really. Rolke argues that right now CPOs are drowning in support tickets. Cable stuck, payment failed, screen is broken. You just can't hire enough people to answer all those phones.
So the lights out idea is what, self-healing chargers?
Ideally, or at the very least, self-diagnosing. The system should know why a charger is down before a human even looks at it. It should try to reboot itself or reroute power or automatically dispatch a technician.
That sounds great, but Marco Muller raised a point that suggests maybe we aren't quite there yet.
Muller is the one saying, stop testing on your customer. He says that phrase, works in the lab, is so dangerous. Because real-world EVs are messy. They have old software, buggy protocols. The grid fluctuates.
He's pushing for more simulation.
Software in the loop and hardware in the loop testing. You have to simulate thousands of scenarios. Bad weather, a 2018 car with old firmware, a voltage spike before you deploy. Because once that charger is in the ground in rural Nevada, it is way too late to debug.
And it's not just bugs we have to worry about. Christophe Lefilibert brought up something much darker. Cyber threats.
This is the elephant in the room. We treat chargers like simple appliances, like a toaster or something. But they're internet-connected computers controlling extremely high voltage.
And they're payment terminals.
Exactly. Lefilibert is warning that chargers are already being hacked. User data is being stolen. But the bigger risk is business continuity. Imagine a fleet operator getting hit with ransomware. Pay us 5 Bitcoin or your entire truck fleet won't charge tomorrow.
That stops the whole supply chain cold.
It's not an IT problem anymore, it's a national security issue.
So reliability isn't just about fixing the plug, it's about digital defense.
Correct.
Okay, let's slide into our final theme. We've talked about getting power to the vehicle. Now let's talk about the vessel that holds it. Battery tech and circularity.
And this is where we run into a math problem.
Right. Christopher Lund flagged this specifically about the EU battery regulation.
It's a classic case of, well, regulation getting ahead of reality. The EU has mandated that by 2031, new batteries have to contain specific percentages of recycled cobalt, lithium, and nickel.
Which sounds great on paper. We all want a circular economy. We want to recycle batteries.
We absolutely do. But Lund's point is that the urban mine is empty.
The what?
The urban mine? The pool of old batteries ready for recycling. It's empty because the cars are lasting too long.
Oh, that's a paradox.
It's a huge paradox. We're building better batteries that last 15, maybe 20 years. That's fantastic for the consumer. But it means the millions of EVs we're selling today won't be scrapped until the late 2030s or even 2040s.
So in 2031, the recyclers will be standing there, shredders running, waiting for batteries that are still happily driving around on the road.
And the regulation mandates recycled content that physically does not exist yet. We are mandating a harvest before the crop is even grown.
That is going to be a tough squeeze for manufacturers. But there is a step between the car and the shredder, isn't there? Second life.
Yes, and Tobias Nichel shared a fascinating case study from Zenobia that shows this is happening right now.
This wasn't just, let's put an old battery in a shed. They used second life batteries to solve a real construction problem.
Right, so when you build a massive wind farm, there's this weird catch-22. You need power to test all the systems before the final grid connection is live. Usually they just bring in massive diesel generators.
Burning diesel to start a wind farm, the irony is just thick.
It is. Zenobia used Second Life EV batteries instead. They provided all that startup power. And Nichel noted they saved 260,000 liters of diesel. But more importantly for the business case, they cut 6 weeks off the commissioning time.
6 weeks is real money in construction.
Huge money. And it proves that a battery that's maybe too tired for a high-performance car is still an incredibly powerful asset for the grid.
And speaking of batteries as assets, we have to mention the movement on V2H vehicle to home. Manfred Prisabilla and Philip Gotthard were discussing the BMW rollout.
This feels like the final piece of the puzzle. BMW is rolling this out in 13 markets. It's not a pilot anymore. This is a commercial product.
And this lets the homeowner run their lights or their dishwasher using the battery in their car.
Or keep the whole house running during a blackout. It fundamentally changes the psychology of an EV. It's no longer just a car. It's a backup generator on wheels.
So we've gone from the grid is a bottleneck to the car is now part of the grid.
That is the full circle right there.
So looking back at these 2 weeks, it really feels like the industry's growing up. We're dealing with very unglamorous problems, grid queues, reactive power, recycling shortages, but the solutions are getting really sophisticated.
That's the takeaway for me. The word is integration. We're done with the phase of just planting hardware in the ground and hoping it works. Now, the grid connection, the software, the battery storage, the vehicle itself, it all has to talk. If you're building a site without thinking about flexibility, you are building a liability.
And if you're buying trucks without solving for that dead time charging at the dock, you're just leaving money on the table.
Exactly. The easy growth is over. Now comes the smart growth.
Well, that wraps up this deep dive into electrification and battery tech for weeks 4 and 5. We really hope this helped you find the signal in the noise. If you enjoyed this episode, new episodes drop every 2 weeks. Also, check out our other editions on future mobility and market evolution, next-gen vehicle intelligence, and commercial fleet insights. Thanks for listening, and don't forget to subscribe so you never miss a deep dive. Catch you next time.